I've done 3 different programs to solve a system using matrices through Gauss and back substitution. Each of these programs will use one for loop less. The first one will use 3 loops. It's called forward 3 loops, and the first one through I is going to loop through the columns, while the second loop using J is going to loop through the rows, and lastly K is going to loop through every single value of a row in order to operate on it. To do that, we will use 2 variables, auxiliary variables called aux1 and aux2. These variables are going to store the values we're using to multiply the rows, and that's what K is going to use in order to get zeros under the pivots. And then we're going to print the matrix. Forward 2 loops is a function that uses, instead of 3 loops, only 2 of them. Y for the columns, J for the rows as well. However, instead of using K, we're going to use eigen, a mathematical library that is going to operate on the whole row at the same time. To do that, we will get a factor that's going to be the pivot dividing the row we are operating on, and then we're going to use this factor to operate on the row. And lastly, we're going to use a vector for the free variables that are not multiplying any unknown value, and we're going to use the factor to operate on them as well. Augmented is a vector that stores all the free values. Lastly, with for 1 loop, we are still going to use the eigen function to multiply a single entire row, but we're also going to use, instead of 2-dimensional matrix, we're going to simulate as if the matrix was a single very long row. To do that, we're going to get the column and we're going to divide I. It's going to grow from 0 to the max number of cells we have. In 3 by 3, for example, is 9. And we're going to divide it by the number of rows. Since it's an int, it's not going to count the fractionary values, and it's going to stay at meaning columns, is going to stay at the same exact point until we get to another column. Meanwhile, row is going to do the same, but for the rows. This said, now we will use col as I and row as j, but only using one for loop. That said, we're going to use these values to do a similar operation on entire rows using eigen. This function will then solve a matrix by back substitution. However, this function is only usable for the forward 3 loops, since it's using a 2-dimensional vector. However, I have created another function to do back substitution using eigen. It's the same, exactly the same, but using the different information type. for the matrix, we're going to use this one, and for the forward 3 loops, we're going to use this matrix since it's a 2D vector, and for the forward 2 and forward 1 loop, we're going to use this matrix since we were using eigen. As you can see, the program compiles. We start with this matrix. We end up with this one. And finally, here we have our result. This is the forward 3 loops. We'll next have this matrix with these independent values. We will apply Gauss to it. And once we have it, we'll get its values. For the forward 2 loops, we're going to use this matrix that is going to give us the same matrix but with Gauss applied. The last 3 values are the independent values. Once Gauss is applied, we are going to solve it and it's going to give us these values. We're going to use the same matrix for the forward 1 loop, and it's going to give us the same matrix using Gauss with the same results.